All right, so just as a quick review of what we did last class, we talked about expanding problems that fit a couple different patterns. We talked about the expansion for the sum and difference of terms. When you expand this out, write it in a polynomial form, what's our first term going to be here? We square the 5x, so we get 25x squared. And then the second term is going to be negative 7 squared, 49. Okay, so this should be something that is extremely familiar to you, that you can do it no problem. You should never have to use a calculator to do this type of a problem. And now, the next type of problem that you need to be able to solve by hand is a binomial square. And again, the pattern for this, you take your first term and square it. So we get 5 squared, which is 25x squared. Then you take the product of your terms and double that product. So 5x times a negative 7 is negative 35x. When you double negative 35x, that gives you negative 70x. And then your last term is this last term squared. So negative 7, that whole quantity squared, is plus 49. And so once again, it winds up giving you your solution. It's pretty easy. It should be faster than if you tried typing that into your calculator. And so make sure that you're comfortable with that. Now, the thing that you're going to see in the next section is not only do you need to be able to go from left to right, you're also going to need to be able to go back the other direction and factor these. So you do want to be familiar with these because you're going to be moving back and forth between the different forms. All right, the only other one that we talked about yesterday was the form of a binomial cube. And this is the one that was, again, probably new to everybody. When you expand a binomial cube, the easiest way to approach it, in my opinion, is to set it up using the pattern of coefficients, 1, 3, 3, 1. Again, if you don't remember that, you should be able to recreate it pretty easily just using Pascal's triangle to come up with that coefficient set. And then you're going to take your first term, which in this case is just an x, and then each consecutive term you're going to decrease its power. So x cubed, x squared, x to the first. And then do the same thing with the second term, in this case a negative 3, and move backwards from the right. So negative 3 cubed, negative 3 squared, negative 3 to the first. And once you do that, all you need to do to finish this off is to simplify. So here we cube our x. Here we multiply negative 3 times 3 gives us negative 9 times the x squared. Here square the negative 3, that becomes a positive 9. So again, the negative takes care of itself in those. 9 times 3 is positive 27x. And then our last term, negative 3 cubed, is negative 27. And so we're able to get this whole expression written out. Okay? All the negative signs take care of each other. You don't need to memorize more than one form of that. And you do not have to know how to work backwards from this. So we're only going to work from the expansion form. All right, so that's what we talked about last class. Were there questions on any of that?
What if it was 3 minus x?
If it was the other way around?
Yeah.
If it's the other way around, you do it the exact same way. It's coefficient pattern of 1, 3, 3, 1. Take your first term, which now is 3, and we're going to cube it, square it to the first. Take your second term, which is now a negative x. Again, always take the sign with it. You're going to cube it, square it to the first. And when you combine your terms here, we get 3 cubed, which is 27. Here the negative comes out. We have 3 squared, which is 9. 9 times 3 is 27, so we get a minus 27x. Here we square the x, so it becomes a positive x squared. So we get plus 9x squared. And then here negative x cubed becomes a negative x cubed. And now, again, when you write your answers, what I want you to do is make sure you write them in standard form. So we reorder this. and put our highest degree term first. And so this is what we get. Now, would it make sense that these two answers are just exact opposites of each other? Each individual term is the exact opposite. And that should make sense, because really what you could do is, if we took this whole quantity right here that's being cubed and we factored out a negative, we change this 3 to a negative 3 and this negative x to a positive x. Now understand, this is still within that, it's still within that power of 3, but what is the value negative 1 cubed? Negative 1, and then you have this x minus 3 cubed, which is this expression. And so it should make sense that when you flip them, 3 minus x quantity cubed, you're just going to get the opposite of each of those terms. But it works that out that way too if you factor it first. Any other questions on those?
Could you not just take it out, like 3 minus x, 4 minus x, 4 minus x? Could you just do that?
If you want.
Like, could you just take it out?
Right, so the other possibility, if you don't remember this pattern, what you would have to do is you'd have to multiply these two together or use the binomial square pattern. And then whatever you get from that, then you'd have to take x minus 3 times that whole quantity. Okay, so you could do it that way and just distribute in steps.
Yeah.
Okay, but if you can remember the pattern, it winds up being a little bit quicker. Other questions?